Hello and welcome back. Today I want to do a few changes to the JUNTEK because I think about 2 weeks ago or a few weeks back I did the hands-on of the JUNTEK signal generator, the PSG 9080. It's a 80 megahertz signal generator, and yeah, if you compare it to the FieldTech, I like that the display is very big, but was one downside, and that was the internal oscillator was a little bit off, and so the frequencies that you put out are not that exact. And for a lot of people, that is not a problem. But I like to connect everything to my external reference. I did those modifications already to the FieldTech. In the internal oscillator, there was 10 megahertz, so that was easily done. Here, the Unity, the UTG962E, I also made the external reference modification. That one runs on 50 megahertz, so I use there my PLL, and the PLL is also connected to the external reference. So that worked. The same we need to do with the JUNTEK. The JUNTEK also runs on 50 megahertz, and we already mentioned that. So have a look. Looking again at JUNTEK, I really like its bigger size and the bigger display. There are a few things that are maybe nice and maybe you don't like. For instance, that they have they have here the Earth connection, so you can connect it with the Earth because the signal outputs are actually floating. And sometimes it is nice, but sometimes also not nice. So I also gonna make a modification to that. And instead of using this Earth connection that I need to connect somewhere, I'm just gonna connect this internally to the Earth pin right here with the switch. And then I can just select with the switch if the front is floating or not, because I don't want them to float, because it can maybe in the FieldTech, I remember it could go up to 24 volts or 40 volts. Some people even report it. And here it is still a few volts, but well, we're gonna open it and have a closer look. We already did some quick tests, and it was indeed 50 megahertz. It's not a problem. I just program another port to 50, and I just need to look again to see what is the best solution where we put the switch, because of course I want to make it switchable, because if I don't have my external reference or I bring it to a friend, then I need to be able to switch it back to the internal reference. So here we have it. So okay, I opened it, and maybe if you can remember from the review, we found here the earth wire that is connected just with a little screw in the back. And I think there is a much better solution for this, because you already have your earth wire here. So what you can do instead of here, this is just a little screw. It's just touching a little bit of metal. And this is not the best contact you can have. So I was thinking to solder it here on this point. I already measured this point is also an earth connection. It connects to this. So if we can make it switchable, I just connect the wire here to the earth connection here. And we have a little switch just here. And then we can just switch it over from floating to real earth. So that is the one idea. And then we have also the external reference. We find here the little oscillator. It's also 50 megahertz. And just like in the Unity, there is a little resistor here. I think, if I remember correctly, it was like 30 ohms. We can just remove this one. There are not too many components around it. I will zoom on that later. And then we could just inject the signal here and also make it switchable. So when you don't have your external reference available, especially because it is 50, maybe you have, and then it's 10, then you can just switch it over to internal. Let me zoom in a little bit here. Now we have a little bit of a better view. Oscillator here, resistor here, and that goes right into the IC there. Okay, I'm now zoom in a little bit more. I will try to, so we have the oscillator right here. And then just like in the other signal generators, it goes through, this is a 330, so it's around 30 ohms, 33 ohms. And then it goes right to the big IC. And yeah, so I'm gonna remove this resistor and then try to get from there. If you have not seen my other video, I will just measure again. I will zoom in a little bit. Hopefully you can have a view on the scope. And I can also make a screen dump of that. So I will zoom in. Yeah. Then if I measure exactly on that resistor, you can see on the oscilloscope, this is exactly 50 megahertz. But it depends a lot on the temperature because it was a lot off. But now it seems to be good. That's funny. So here we have a peak of 1.19 volts, and if we go on the other side, we have here 1.34 volts peak, and that is exactly what I also get out of the PLL, the 6-channel PLL right here. So that is perfect. So I will just need to remove this resistor right here, the R55. Okay, I will try to zoom in what I'm doing. I have not enough space to put the microscope. I have here my rework station. I put a very tiny point on it. And I will zoom in, try to make the resistor hot, and then push it away. Okay, I need to remove some of the cables to have a bit more space. Okay, that worked. The little resistor is here. I can try to zoom in. It's super small. Here it is. I will get a microscope. Okay, in the microscope you have a much better view. Indeed, we took the right resistor. It's the 330, 33 ohms. Let's see how it looks on the circuit board. This is what it looks like on the circuit board. You can see the resistor is removed. I changed the really pointy on my soldering iron. Let's try to clean this up a little bit. And here we can put our wires to make it switchable and to inject the signal. I will clean it a little bit with EPA. I just have a cut and stick and a little bit of EPA. Well, it looks huge under the microscope, but clean a little bit of the flux. There's a little bit in between. Let's try to get it out too. There it is, nice and clean. Okay, these two pads we need. I try to position the camera that you can see what I'm doing without it bothers me. Yeah, the grounding. The BNCs are floating, but not floating to this ground and not floating to this ground. And also here is a ground point. So instead of using this grounding that you have here, then you need to put a separate wire and you need to put it all the way to your ground point. While in all the European plugs right here, you have this big ground pin. There is just a ground pin right here in the bottom. So it's much more easy to remove this, connect it to this ground point, connect it to this ground point and put a switch in between exactly here. Then you can just switch it on and off and you don't need to put any extra wires. And also, the ground point here, it's just with a screw. So it works now. If you look at the Gidley, now it works. But if the screw is somehow a little bit loose, the contact is not that good. So it is a bit of a silly system. And then, yeah, well, we are lucky it works now because. So that is not ideal for me. For me, it's not acceptable, to be honest. So I will take this loose. And remove also this. I will just remove the screw completely. To take it out. So then there is just nothing here. Perfect. I can use it all maybe for the external reference. I think that is fine. And then this ground point is just going to be here, connecting to here with the switch in between. Okay. Make a little cut right here. Okay. That's a good fit. Also, this probably needs to be soldered because this is also just a little screw. Yes, I will do that. Okay. That is that. Now we like to connect this here, but we need a little switch in between, and then we put it in. Now we get the next to the wire, put the switch right there. Okay, let's drill a hole right here. Okay, well, I have a little collection. I have some push buttons, but I will just do a switch. Well, the voltage doesn't matter too much, it's just grounding. I can use singles, but I can also use very small ones. But I have enough space, the thing is big, I will just use a big switch. And yeah, I can use, they're the same. Okay, I will drill the hole. I always start small. And I don't know, they taught me this in school, and I like it. You just start always with the small, that you don't push too much force, especially for metal, but I like the idea also with plastic. Oh. So, where I would like it, exactly here in the C, why not? Yeah, this one is broken. We take a smaller one then. Yeah, that's small to start. And we probably need to get to 5, so I will do first of 4. And then if you have a bigger drill, or one like this, you can just clean it a little bit. Okay, so that is done. And I will put the switch. Okay, well, the switch we need to adjust a little bit that it doesn't stick out too much, but it is also not, we need enough threads to get the nut fixed. And I think somehow it feels good that if it's down, it is connected to ground. And then I will just put the ground sign here. Doesn't look that bad, and I think it's much more convenient than using this weird little screw up there. So, does it work? We just get floating. 3, 2, 1. So I'm just connecting here on the ground of the Euro plug. I'm connecting to the BNC, and now it's floating. And if you don't want that, you just switch it over, and it is not floating anymore. So that's really convenient. And also later, if you change your mind or you need somehow a setup that is floating, switch it over, and it's floating. Why I don't want it floating is I will be using an external reference anyway, so all my crowns are already connected, and most of my crowns are also connected to the real ground, and I don't want any current flowing through my BNC cable, especially not my external reference. So that's why I have this switch. Then I can just ground it through the ground cable instead of through my BNC cables. So I put a little time lapse there, so you don't need to see the whole process of drilling the holes because it is exactly the same as all the others. Here I have on the back, you can see here, that's the crown switch. I put here, it's SMA. I like to do SMA, and why? I have these little cables here, SMA on one side, and just coax on the other. Here it is easy for me to recognize. Okay, it is not the sorry, it is not the standard 10 megahertz because all my 10 megahertz externals have BNC, and that's why it is. I want to put the SMA just to make myself think and realize, okay, it's SMA, so it's probably not 10, so it's something else. And these little, I have also 25, these ones. I also use the clock exit. I use this as an external input here. You can watch of those videos too, but this is also SMA. So I know SMA, okay, I need to connect to my little PLL that I can program to any frequency I want. It has 6 outputs, they can all be programmed differently. So here for the Unity, I did the same for 50 megahertz. So I will just program my output 6 also for 50 megahertz, and the other ones are 25. And all my BNC is 10. So here I also write that 50. I put the switch here. I usually do this, that if it is, I'm pointing to what I want to do. So I put internal, external. Okay, let's continue to connect everything. Here we have it. I try to do a little bit of a zoom. Yes, the switch we still see. Okay, here it is. So what we need to do, here we have that resistor that we remove. And this is the chip. So we take this pin closest to the chip and it goes to the middle pin. Then we take the output of the oscillator that is further away from the chip, but from the oscillator, that we put on the outside pins of the switch. And then when you connect them, it is internal. And when we want the external, we put it on the other outside pin. And then the chip will be selected between the internal or the external reference. And we can put on this line from the line from the oscillator, we can put again the 33 ohms. And in this line, the external reference line, I think I will put 100 nanofarads or 904, just to have a DC block, and that also is sort of a resistance. So then we don't need a resistance here. So that means the middle pin goes directly to the chip, to this pad here, and then here we put a little resistor to the oscillator, and here we put the cap to the external ref. Okay, let's start. Well, external reference is this position, so that means that is this outer pin, and this is internal, so it's crossed. So that means the internal is here. So that means if the internal is here, we need to put the 33 ohms right there. Well, I have one here, 330, as you can see, 33 black. So let's put that first. Sorry, I'm just fighting a bit with the camera position and if I can see it myself. But okay. Okay, so here we have the 33 ohms. This goes between the oscillator here and the chip. So this needs to be the chip. This is the external ref. It is 100 nanofarads. So 104. And we can already connect that. This is ground. I need to add it later to the ground somewhere. This we can just put here. And then we need to add the two wires here. So the chip be the first one right there. Needs to go to the middle. Okay, let's try. I might need some magnification. I will remove this because this is in the way of my cables I need to do. We fix that back later. Let me see if I can get the lighting any good. So I have two little wires here. I think I need to move a little bit like this for me to see a little bit better. Okay. That is one. And this is going to be the second. Let's put the microscope on this. Okay, that is not bad. Nicely soldered, and there is enough distance, so that is okay. Okay, that was soldered well. As we said, this needs to be on the middle pin, needs to be the one from the chip. So we are going to, this is the one from the chip. We put on the middle pin. Right there. Then we have the internal oscillator that is here with the 33 ohms. We put in. Okay, we have that. And then we have the external reference that is through the DC blocker, a little 100 nanofarads cap. Okay, and then the only thing we need to do is connect the ground. So I need to take that from somewhere. I can get it from here, put the wire all the way here. I can take it maybe from the BNCs right here, that is shorter, but I'm not sure. I can easily access that. Also, I have here this screw here. I think I will put that there. And I will just put some soldering right there. Because this was also a ground point, I remember, because that cable went there. I will just get it from there. That is okay. Try not to melt any sticks directly on the PCB ground. Yeah. Okay. How much do I need? Not too much. Okay, the cable is still hot. Okay. Let's connect it here. It is all done. Let's zoom in a little bit so you can have a better view on what happened. So let me point. So this side is the oscillator. It goes to the outer pin, through the resistor, and then through the middle pin, back to the chip. Or it goes from the external reference, here to ground, through the cap, through the middle pin, to the chip. Let's do some testing. Now we need to test what we have done, just to see. So let me get the power. I switch it to internal reference. That's what we need to check first, if it even powers up. And maybe we can have a look to the signal that it outputs. Frequency on A. Let's put a little BNC. A short one right here. And this is a little bit too short. This one. Let's see if it even works. Yes, it still works. And it is a little bit off. But I think there was also, but it kind of works. I think in system you could also put some sort of correction, but of course we're not gonna need the correction later. Okay, so it works. Now we switch it off. Now we try external reference. We can see what the signal looks like. Maybe I need ground. I have my ground point and I have the oscillator. It helps when it's switched on. I'm checking on the pin. And I have a signal of 1.19 volts peak. So the resistor does its work. That is good. Yeah, let's check if we do the external reference. You always need to switch it off when you switch over. just to, because the processor will crash, because it's also the processor clock. This one was already 50 because it went to the Unity. I will show later how to program the PLL. I output this. I connect to the external ref connection. We need to switch over the switch. Let's have a look because the signal should already be there. Even it's not switched on. My ground point come. Yes. And then I'm looking on the how much I have here. Oh, 1.4. So that is loud, but that is okay. Signal looks like the same. Okay, let's switch it on. The frequency is still off. Maybe that is still the correction. I'm a bit surprised why that is. Well, I do remember there was this correction setting that you could do. System, page down, here, frequency fine tuning. So let's go to that. And I think the default was 50, but we put it to 70 just to, no, it is immediately working. I don't like they put this correction because the whole thing of external reference is that it is looking at your reference. Okay, that is a pity because it doesn't listen fully to the external reference because they built this correction in it. And I really would have liked to be able to switch it off. This is, but it does improve the system, this external reference, because if you can see now it is at 10, so it's 2 or 3 hertz off. And if I switch it to external reference and I switch it back on, it does improve a lot because now it is less than 1 hertz. Maybe it's more easy to see if I round it like this. But so it does improve, but I would have thought it would be spot on. But what I have here is here this correction factor, frequency fine tuning. And that is a pity. You cannot switch it off because you would have liked that it is fully listening to the external reference, which is it not, because you can still correct it. So the correction is now actually working against us because I can put it a little bit lower and it is a lot lower. And if I put it higher, it is a lot higher. So there are no steps in between. So I would have liked that you can actually switch this off. I switched it back to internal reference, and now I like to see how is the internal frequency counter, how is that synced with the processor. I will get here the 10 megahertz, put it on the input, switch it to frequency counter, and let's see what it says. It says now it's 10.00084, so it means it's 84 hertz off. Let's see what happens if we do the same for external reference. Switch it over, switch it back on, measure, and now it is only 77 hertz off. And I would have loved if this was just exactly 10. Okay, and then why is it not listening to the external ref? Well, I think that is that correction option that you have, you can change. And first I want to check, does it have to do something with that the reference is not good? Well, this is the internal reference. As you can see, this is a little bit off. So we expect here that it is a little bit off. If I measure my external ref, it is perfectly 50. So then I would expect this device also to be perfectly spot on. Okay, I'm trying it now on 80 megahertz, and if we output the 80 megahertz, then we are 1.1k off, which is a lot. And if we put it to external reference and we try that, then we are 6-7 hertz off. So in that sense, we improve a lot, but it is just a pity that that it's not spot on. I would have expected that. So if you wonder how does that PLL work, I have here a little program. It's also from the BG7 TBL, and we can switch now to English. I connected it to COM1, OpenCom. It will be connected, it will read all the settings. As you can see, a program port out to 10, to 10, to 1. This is where my Unity is connected, and I will do port 6, that is the other one on the left. I will program to 50 megahertz. This is probably the right button, right. Now it's written, I can close the COM port, and that's it. Now we have port 4 and 6. We have to 50 megahertz, and this PLL is of course also connected to external reference 10 megahertz, my GPSDO. So this is great if you need other frequencies, like here I have the 25 for the little oscillators. Okay, that worked a bit. I'm not sure you should go through all this trouble just to get it a little bit better. I really would have liked that it would be spot on, and it should be possible because we use external reference. But because they have this software correction, it's now actually working against us. The modification for the ground switch to make it float or just on the ground, that I think that this is great. But yeah, it did work a little bit because the frequency counter, instead of 10 megahertz and 88 hertz, I think it was off, it was now 77 hertz off, which is still off. And yeah, on 80 megahertz, the signal generator, instead of being more than 1k off, it was like 7 or 8 hertz off. So it did work, but yeah, as I said, I don't think you need to go through all this trouble. It's just the software works against us. Hope you liked it anyway. Thank you for watching, and hope to see you next time.